Hi students, this is Mr. Yao. In this lesson, we are going to learn more about graphing quadratic functions. First, the last form we can graph in, which is vertex form. Let's quickly remind ourselves about vertex form. Vertex form is by completing the square, and it looks like a times x minus h squared plus k. The vertex, of course, is h, comma, k. Now let's graph from vertex form. Of course, with vertex form, the first thing to identify very quickly is the vertex. Remember, the h has to be the opposite number inside the parentheses, so it's -1, then comma, -3. -1, comma, -3, right there. Next, y-intercept. Even though it's not the easiest to identify the y-intercept like in standard form, because in standard form, again, the y-intercept would just be the 0, c. In this case, we don't have the c, so we do need to plug in the 0. 0 plus 1 squared is a 1, minus 3 is a -2. So the y-intercept is 0, -2. Right here. And as soon as we have the vertex, we also have the x-symmetry, which is x equals -1. It's always the h value. So let me draw the x-symmetry, because with the x-symmetry, we can actually start reflecting points. We got a 0, -2 that can be reflected to the left side, with which is going to be a -2, -2. And then, now we just need one extra point. These 2 points are both 1 away horizontally from the vertex, so we can just go 2 away. So let's find, you can either find f of 1 or you can find f of -3. They would probably give you they would actually give you the same value. 1 plus 1 squared, which is 2 squared, which is 4, minus 3, that's a 1. So the one extra point we can have is 1, 1. That's 2 away from the x-symmetry reflected over. We got our 5th point, and then we can just connect all of these 5 points, and that's our problem. That's graphing from vertex form. Let's have a look at one more example. First, the vertex, 3, -4. Right here, 3, -4. There you go. Oh, actually, they're right there. Okay, y-intercept, we're going to plug in f of 0, plug in 0, so it's -2 times 0 minus 3 squared minus 4. 0 minus 3 is a -3, squared is a positive 9, -2 times a 9 is a -18. Again, you have to deal with the square part first, then multiply with a -2, so it's -18 minus 4, which is -22. 0, -22. Well, our graph is not enough, so we're going to just find the important points instead of graphing them. X-symmetry is from the vertex x equals 3. As for the 1 point, 0 and 3, there's 3 in between them, so you can either do f of 1 or f of 2 or f4 or f of 5. So you want to find f of 1, -2 times 1 minus 3 squared minus 4. So it's -2 times, that's -2 squared, which is a 4, and minus 4, so it's -12. 1, comma, -12. That's the one extra point that we can use. So that's example 2, which is finding a vertex form. So let me actually move that up. So after you plug it in, it's going to f of -12. And of course, with vertex form, it's the easiest to identify the vertex. And that's, of course, the first point we're always going to go for, h, comma, k. And make sure it's the opposite of the number inside the parentheses. And then y-intercept is also a very useful point. So we can find y-intercept. Then based on the position of vertex and y-intercept, we can find other points in between. That's graphing from vertex form. Moving on. Now, connection between quadratic formula and graph. So we learned about discriminant when we were solving quadratic equations, which is b squared minus 4ac, which again comes actually, what will actually appear inside your quadratic formula is this very important part, which is under the square root. So we had, when we learned about equations, we actually had 4 different situations. Inside the greater than 0, we had perfect squares and non-perfect squares. So that's actually going to give you different results for your 2 solutions. In here, well, they're just both greater than 0. So when that b squared minus 4ac is greater than 0, we actually have this square root part giving us an actual number. So we have 2 real solutions. When we learn about equations, the 2 real solutions, one is going to be rational, 2 rational equations, and the other is going to be 2 irrational equations, 2 irrational solutions. And of course, because there are 2 solutions, they're corresponding to 2 x-intercepts, and they're 2 distinct x-intercepts. Let me draw a graph. I actually don't need that. So whenever we have a quadratic, this axis symmetry is negative b over 2a, which again is actually the first part of your quadratic function. And then you see as soon as you have that value, you're going left by a certain amount, or you're going to the right by a certain amount. That's why we have the plus and the minus. So if the discriminant is greater than 0, that means this distance that you're moving to the left and the right are actually going to be positive. So that's why you actually do have 2 points, 2 distinct x-intercepts. Next, x equals 0, well, that means this b squared minus 4ac part is just a 0. So when you do a plus minus 0, well, that doesn't change the whole thing. So you actually have one real solution. And that means you also have one intercept. So on the graph, when you have your axis symmetry, let's say x equals negative b over 2a, then you have this point on the x-axis. Well, if it's a 0, that means your distance moving to the left and moving to the right is going to be 0, which means it's not actually moving. That's why the x-intercept will just be your vertex. So it's one x-intercept. Then when it's less than 0, well, you don't have any distance. You can't move a negative distance. So even if you have a axis symmetry, well, on here, you're not moving, you can't move a negative distance, so that means you're not even touching that point. But your graph would actually be not touching, so you have 0 x-intercepts. You don't have any x-intercept. But of course, these are just one situation if your graph opens up. It could also open down, and then you're still going to have either 2 intercepts, 1 intercept, or no intercepts. So now it's time to practice. We are just going to use the discriminant to identify what kind of x-intercepts we may have without graphing them. So first one, b squared minus 4ac is 20 squared minus 4 times 2 times 50. So it's going to be 400 minus 400, which is a 0. So you're going to have one x-intercept. Next, negative 2 squared minus 4 times 2, oh, well, not 2, 4 times 3 is 5, which is a 4 minus 12 times 5 is a 60. So it's negative 56, which is less than 0, so no x-intercept. And then lastly, well, this one, that's your A, that's your B. Your C is actually a 0 because on the end you don't have a number, so it's just going to be a 0. B squared is 14 squared minus 4 times 2 times 0. You're going to get 14 squared. Well, you're going to get 196 minus 0, so it's just 196. It is greater than 0, so you're going to have 2 x-intercepts. There you go. That is the last lesson for graphing quadratic functions. Thank you.